In this video, we'll learn how to make a pH calculation when we're given the concentration of just one of the ions and not the other. And we'll also find a shortcut method that will involve other p scales. So how about that? That sounds pretty cool, right? All right, so for instance, let's say we've got a pH of 8.4. And we want to know, is that acidic, basic, or neutral? Well, if we assume we're at room temperature, then anytime the pH is above 7, it's going to be basic. Now, what we want to do now is calculate the concentration of hydronium ion and the concentration of hydroxide ion from that. So what can we say about those two? So here's where we've got to go back to definition. So we know pH is the negative base 10 log of the H plus concentration. So we can manipulate this and show that the H plus concentration is 10 to the minus pH. So for instance, if we want to know the H plus concentration of our sample here, it would be 10 to the minus 8.40. Now, here's where we have to keep track of significant figures. So the number of decimal places in the pH becomes the number of significant figures in the concentration. So if we've got 2 decimal places here, at the end of the day, we're going to need 2 significant figures here. So it's kind of unusual. Every time in this course so far, we've almost always ended up with 3 significant figures, but here we're going to end up with 2. So if we take 10 to the minus 8.40, our calculator says 3.98 times 10 to the minus 9. I'll actually keep that as a guard digit, so I should really say 4.0 times 10 to the minus 9 moles per liter. There, so I got to remember to put that in. Now, what about the concentration of OH minus? There's a couple of ways to do that. So one way we can go back to Kw. We can say Kw is the concentration of H plus times OH minus. So if we want to find OH minus, we just rearrange it as Kw over H plus. So Kw, remember that at room temperature, right? It's 1 times 10 to the minus 14. And we got 3.98. So again, we're keeping a guard digit just because we're doing another calculation. And when we round off right, we can start to build up error if we're not careful. And this comes out to be 2.51. Again, that one's a guard digit times 10 to the minus 6. We got to put in the units at the end of the day. That's moles per liter. And again, we can see that that concentration is bigger than the other one, right? So 10 to the minus 6 is 1,000 times bigger than 10 to the minus 9. So it's basic because this concentration is bigger than this one. However, we can also just look at the pH and say if it's at room temperature, above 7 is also telling us it is basic. So in this section of the video, we're going to look at some other P scales. So what do I mean by P scales? Well, we looked at pH, and pH we said is the minus base 10 logarithm of the concentration of H plus. However, it's going to be very convenient to define another P scale called POH. And POH is the negative log to base 10 of a different concentration, and that is the hydroxide concentration. So notice the P, if you like, is almost the same as minus log of the concentration of All right, so what use is this? Well, if we go back to Kw, so Kw is the concentration of H plus times the concentration of OH minus. And if we take the negative logarithm of both sides of that equation, we get negative log Kw, okay, is negative log, and this whole mess here, H plus OH minus. Now, through properties, of logarithms, we know that the log of A times B is the same thing as the log of A plus the log of B. In fact, logarithms were invented as a way to make multiplication turn into an addition problem. So we can go ahead and we can simplify this side and say it's the minus log of H plus, okay, plus the minus log of OH minus, and then we can start calling these things P functions. So we can say this is the pH, and we're adding to that the minus log of OH minus, so that is the POH. In fact, if we take the log of Kw and flip the sign, we get 14. And we could, I suppose, refer to that as the pKw. In fact, in analytical chemistry, we probably will. So just kind of squirrel that thought away. So pH and POH add up to 14. So this gives us actually another way we can do a acid-base calculation very, very quickly. So for instance, if the concentration of OH minus in a problem was something like 1 times 10 to the minus 3, and we wanted to know the pH, right? You might say, well, that's actually kind of a long calculation. But instead, what we can do is we can turn that into a POH. We can find the negative log of 1 times 10 to the minus 3. All right, that is just 3. And if we want to turn that into a pH, we just basically subtract POH away from pKw, right, away from 14. and that gives us 11. And I think it's a lot easier to look at that and to calculate a pH that way than to go through the mess of saying, well, Kw is H plus plus OH minus, so if we've got this and we know this, we can solve for this, and then we can negative log it. I just think it's much easier. You just immediately start with the OH minus concentration, you negative log it, turn it into a POH, and then remember that pH and POH add up to pKw or add up to 14. And if we put it all together at room temperature, so again, we're at 25 degrees C, we've met our pH scale before. We know our pH scale looks something like this, so 7, and then 8 and 9, that's more basic, and 6 and 5, that is more acidic. Well, pH and POH add to 14, so what that means is if the pH is 7, the POH is 7. If the pH is 6, it means the POH is, yep, that's 8. If the pH is 5, the POH is 9. Okay, or, if the POH was 6, that means the pH would have to be 8, and so on. So we're just basically keeping these adding up to 14. So at any particular value, right, we can see that neutral corresponds to pH and POH of 7, and acidic corresponds to POHs greater than 7. Okay, I should write POH there. And notice it also corresponds to pHs less than 7. However, if you are a neutral solution, right, your pH and POH is exactly 7. But if you're basic, right, in terms of pH, your pH is greater than 7. But if you are basic, your POH is less than 7. So the POH scale is actually kind of nice in one way, because every time the number is bigger than 7, you've got an acid. And I always like to think about pH as an acidic scale, but it's actually a measure of basicity. But POH is a measure of acidity. Bigger numbers equal more acidic solutions. So I think that's kind of cool.